Hello everybody, so in this presentation we will be discussing heat. This is a long presentation. We'll be discussing what exactly heat is, how it moves, and really at the microscopic level also talking about heat. So get ready. Heat is the flow of energy from a warm object to a cooler object. We see this in many different places. We can find it anywhere, and all matter contains heat energy because all matter is composed of particles that are always moving. Thermal energy is the total energy, kinetic and potential of the small particles in an object. It can be transferred from one object to another. Now, thermal energy is the result of the movement of these tiny particles of matter. And particles can be things that are very small, like atoms, molecules, or ions, and matter, which we'll review shortly, is solid, liquids, or gases. As we're talking about thermal energy and we're talking about heat, I want you guys just to pause for a minute and think about what happens when you put ice in a glass of lemonade, especially during the summertime. We know that what's going to happen is that over time that ice is going to start melting in that glass of lemonade. It's going to make the lemonade cooler. So what's happening here is the lemonade is transferring that heat to the ice, making the ice melt. And eventually both the lemonade and the water from the ice are going to be the same temperature. This is called thermal equilibrium, when two different objects reach that same point. I mentioned at the beginning that heat can be found anywhere because all matter is generating heat. Remember that matter is anything around us that has mass, volume, and takes up space. Now, matter can exist in different forms or phases. It exists as solids, liquids, or gases. And again, matter is made up of these tiny particles, molecules, atoms, ions that are constantly in motion, which is causing heat. So again, matter can exist in many different phases. The first phase the phases are solids, liquids, and gases. So as a solid, we're going to see the particles being packed very closely together. And that's what we see here. It has a very distinct shape as a solid. In the next phase, the liquids, the particles are rolling and sliding around more freely. So you can see here that they have more space around each particle, and it's taking the shape of what it is in. As a gas, the particles are moving around freely, rapidly, and randomly, and you can see that here in this picture. They're going all over the place, and they don't really have a distinct shape. And then finally, for them to move from one phase to another, we need to add energy, we need to add heat. So if we start off with a solid, we need to add some heat for it to turn into a liquid, add some more heat, it turns into a gas, and add some more heat, plasma, which we won't be covering in this classroom. If we want them to go from gas to liquid to solid, we have to remove some of that energy for it to change phase again. So again, just as a quick review, as we're adding more energy in the form of heat, the matter changes from a solid to a liquid and a gas. This actually has a specific name. We call this melting or evaporation. So as it goes from solid to liquid, it is melting. And from liquid to gas, we say that it is experiencing evaporation. And finally, how do we know how hot something is? We can measure how hot or cold something is, and that is called temperature. We measure using a thermometer, and then that is actually telling us the average kinetic energy of the particles in that object. Now, I want you guys to remember that when we use our thermometers, we have to use Celsius. But there are other units of measurement for temperature that you can see here. There's Fahrenheit, Kelvin, Rankine, and Reaumur. But again, in this classroom and in most science classrooms, you will be using Celsius to measure temperature.